Hi everyone, this is Koteswara, Assistant Professor, Department of ECE, Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. Now I am going to explain logical design of IoT. So logical design of IoT. So first of all, what is IoT? IoT stands for Internet of Things. IoT refers to a system of interconnected physical devices that are embedded with sensors, softwares, and other technologies to exchange the data over the internet. This is the definition of IoT. IoT refers to a system of interconnected physical devices that are embedded with sensors, actuators, software, and other technologies to exchange the data over the internet. IoT connects every day, like objects like refrigerators, cars, fans, lights, machines to connect internet so that they can communicate, collect data, and perform tasks automatically. So this is the definition of IoT. Now we will go to discuss about logical design of IoT. So logical design of IoT system refers to a abstract representation of the entities and processes without going into the low level specifics of the implementation. Logical design of IoT system refers to a abstract representation of the entities and processes without going into the low level specific of the implementation. Next, logical design involves IoT functional blocks, IoT communication models, IoT communication APIs. So logical design includes IoT functional blocks, IoT communication models, and IoT communication APIs. So now we will see each one. The first one is IoT functional blocks. Logical design of IoT includes functional blocks of IoT, IoT communication models, IoT communication APIs. The first one is the IoT functional blocks. An IoT system comprises a number of functional blocks are involved in IoT system, and each block provides the specific functionality of the each block. For example, identification, sensing, actuation, communication, and management. So these are the different functionalities are provided by the different functional blocks. So now we will see the each block. So this is the diagram, simple diagram of the IoT functional blocks. So the major blocks are, first one is the device, communication block, services block, and security block. The next one is the management block, and the final one is the application block. So these are the different functional blocks are available in IoT system. So now we will see each one. First one is the device. So in device block, so many devices are involved. For example, sensor device, actuator device, monitoring device, controlling device. These are the different devices are involved. Sensor device can sense the data from the physical environment, and actuator device will gives the output to the physical environment, outside environment. A controlling devices will control the all the system. So and monitoring system will monitor all the entire system. So these are the different devices are involved in the IoT system. The next one is the communication block. So in IoT communication system, different IoT protocols are involved. IoT protocols are handle the communication system in IoT. So different IoT protocols are involved. For example, network layer protocols, data link layer protocols, application layer protocols, next transport layer protocols. So these are the different examples of protocols are involved in IoT communication system. For example, network protocols examples: IPv, Internet Protocol version 4, and Internet Protocol version 6. So these are the Example for network layer protocols. So coming to the transport layer protocols, TCP, TCP, IP, TCP IP protocols are examples for the transport layer protocols. These are the different, and HTTP protocols for application layer, and data link layer, Ethernet, Bluetooth, Wi-Fi. These are the different protocols are involved in IoT communication system. Next block is the services. So like device monitoring, services are like device monitoring, device control, and device publishing services, and device discovery. That means the device history. So these are the services are block will provide the different services functionalities. Next one is the management block. So management block mainly manage all the devices, manage all the system, entire system, by providing the different functionalities, different policies. Next block is the security. Security in IoT system, security block provide the security for the total IoT system to provide the data security. For example, data security. Next message, authorized persons, authorized devices can only send the data. Authorized devices can only transmit and receive the data. So authorization and authentication is also very important in security. Last block is the applications. In this application block, the application also allow users, applications interface the user and allow the user to monitor the system and to view the system status and to analyze the processed data. So these are the different functional blocks are available in IoT. So this is about the first functional block. The next component is IoT communication models. IoT communication models are of 4 types. So these are the 4 important communication models in IoT. First one is the request response model, and the second one is the publish subscribe model, and the next one is the push pull model, and the last one is the exclusive pair model. These are the 4 important communication models involved in IoT communication system. Let's see one by one. The first one is the request response model. So this is the simple diagram of the request response model. So in this diagram, client server are very important, and the client will send the request to the server. So in request response model, first client send a request to the server, then server responds to the client. So this is the process happen here. So in request and response model. So request response is a communication model in which the client sends a request. Client sends a request to the server, and the server responds to the request. When the server receives a request, it decides, when the server receives a request, it decides how to respond and how to prepare the data, how to fetch the data and collect the data from the resources, available resource data from the resources, and prepare a response and then send a response to the client. So this is the happen in the request and response model. So client send a request to the response server, and server will give the response to the client. So client server. So request and response. This is the request and response model. Next we will see the second one, publish subscribe. So publish subscribe is a communication model. In this model, publishers, brokers and consumers are involved in this communication model. So in this model, publishers, brokers and consumers are involved. So see this diagram. So publishers are the source of the data. This is the publishers block. So here publishers are the source of the data, and publishers will send a data to the topics. So publisher will send a data to the topics. So which are managed by the broker. So topics are managed by the broker. So publishers are not aware of the consumers. So publishers only send the data to the topics. So topics are managed by the broker and publishers are not aware of the consumers. So consumers subscribe to the topics which are managed by the broker. Consumers are subscribed to the topics which are managed by the broker. When the broker receives a data, for a topic from the publisher, it sends to the all the subscribed consumers. So this is the process happening in the publish and subscribe. So here publishers, brokers and consumers all are involved in this communication model. So publisher will send a data to the topics. Topics are managed by the broker and that means publishers are sending a data to the broker and broker will send the data to the subscribed consumers. So this is the process happening in publish and subscribe model. Next we will see the next one, push-pull communication model. So in this communication model, publisher will push the data. In the name itself, push and pull. Publisher will push the data to the queue and then consumers will pull the data from the queue. That is the meaning of push-pull. So publisher will send a data to the, that means publisher push the data to the queue. So here queue acts as a first in first out principle. So first in first out means whichever the data entered in first, that is exit first. That is the meaning of first in first out. Here queues help in decoupling the messages between the publishers and the consumers. And queues also act as a buffer which helps in situations when there is a mismatch between the rate at which the producers push data and the rate at which the consumers pull the data. So here publisher will push a data to the queues. Then consumer will pull the data from the queues. So this is the meaning of push-pull. So push-pull model involves publisher and consumers. Between these two, queues are place a decoupling. Queues are decoupling the messages between the publisher and the consumers. So this is about the push-pull communication model. Next one we will see the fourth one and last one in the communication model, that is exclusive pair model. So exclusive pair is a bidirectional full duplex communication. Full duplex means two-way communication at the same time, simultaneously. So full duplex communication. Here once the connection is set up, client will send a request to the server, then server will respond with the request, then connection is established. Once the connection is established, the data exchange between the client and server is continuing. So once the client send a close request to the server, then server will respond with a close response signal, then connection is stopped. So communication is stopped. So this is the exclusive pair, bidirectional and full duplex communication. So this is about the exclusive pair communication. So this is about the IoT communication models. So there are 4 models are there: request response model, publish subscribe model, and next one is the push pull model, and the last one is the exclusive pair model. So these are the 4 communication models used in IoT communication system. Next one is the IoT communication APIs. IoT communication APIs. So API means application programming interface. Application programming interfaces. So here IoT communications are of 2 types: REST based communication API and WebSocket based communication AI. So this is the simple diagram of the communication APIs. So here different devices are there. So these are the different devices. So one device request to a API to send the data, and the API is collects the data from the web server, collects the data from the database to the web server, and API send a response to the particular device. So here API acts as a intermediator between the two. API is a simple software. It interface the between the, it provides the communication between the two softwares. API is nothing but it provides a communication between the two softwares. Okay. So next, types of IoT communication APIs. So here are two types are there: REST-based communication API and WebSocket-based API. So next, let's see one by one. First one is the REST-based API. So REST means representational state transfer, is a set of architectural principles by which you can design web services and web apps. Here REST API follows request response model. So here REST based API follows request response communication model. So here the client will send a request to the, so this is the client and this is the server. So here client will send a request to the server, and then server will respond to the client. So in between these two, so data is forward in the form of packets. Here you are using HTTP protocol. Hypertext transfer protocol are used. By using the HTTP commands, data exchange is possible through the HTTP commands. Here some commands are there. We will see each one. So here get command is used to get the data. So once if the client send a request to the server, by using the get command we can use. Next one is the put command. So put command is used to update that any additional data we can add, or we can edit the data and we can add the new data, update the data. The next command is post. So if we want to post another data, so we can use the post command. Next one is the delete. So delete command is used to delete the total data. So these are the commands, HTTP commands we can use. Next one is the REST payload. Here JSON and XML are there. These are the Python packages are also involved. JSON means JavaScript object notation. So it is like our Python dictionary. It is our like Python dictionary. Key value pairs. Dictionary is like key value pair. For example, age is 11. So this is the age is the key and 11 is the value. So this is the dictionary Python. Similarly, JSON also is like a dictionary key value pair. So age is the key and value is the 11. So key value pairs. Next, XML is also a Python package. So extensible markup language. It is in the form of tree structure. So open tag and close tags are there. So these are the languages, Python packages used in communication between the client and the server. So here this is next one is the resources. Here different resources are available. So whatever the application needed, client needed, then server will provide those particular data from the resources. So this is about the REST-based communication API. So REST-based communication API follows request response model. So request response means client will send a request to the server and then server will respond to the request. So this is about the REST-based communication API. The next one is the next communication API is WebSocket based. So WebSocket API follows the exclusive pair model, exclusive pair communication model. That means bidirectional. So full duplex communication, two-way communication. Once the client send a request to the server, once the server respond to a client, then connection is established. Then so data exchange between the client and the server until the request, close request is sent to the client to the server. Next server will close the response until the communication is continuing. This is about the WebSocket based communication API. WebSocket based communication API follows the exclusive pair model. So these are the types of IoT communication APIs. Next we will see the difference of REST based and WebSocket based. So based on the state, so REST based follows the stateless communication and so WebSocket follows the stateful communication. And based on the directional, so REST is examples for unidirectional, WebSocket follows the bidirectional. The next coming to request full duplex, reset for REST communication API follows the REST request response model and the WebSocket API follows the exclusive pair model. So next connection wise, REST based follow the HTTP request, and whereas in WebSocket so involves a TCP IP connection. Next coming to REST, here each request carries a HTTP header, hence not suitable for real time. So REST is not suitable for REST communication API is not suitable for real time. So whereas in WebSocket, so does not involve overhead. So it is useful, it is suitable for real time. WebSocket is API is suitable for real time. Next is scalability. So both horizontal and vertical are easier. So in REST based API, both horizontal and vertical are easier. So in WebSocket, only vertical is easier. So this is the difference between the REST based API and WebSocket APIs. So this is my class about so logical design of IoT. So once we see what we have discussed. So IoT definition, so logical design of IoT. So logical design of IoT involves IoT communication functional blocks, IoT communication models and IoT communication APIs. So this is the lecture. Thank you.